Okay, good morning, afternoon, evening, wherever you are. This is IB Math Studies, Topic 6, Functions. So we're going to do a formative assessment, start with this paper 1 question involving quadratics. Okay, so we look at the given information here. We should be able to make a nice sketch of the quadratic function. So x and y axes, and again, the y-intercept is at 10, and one of the x-intercepts is 1. So it must go something like this, okay? They give you a little bit more information about the vertex of the graph is at 3. The x-coordinate of the vertex is at 3. So this is what defines the axis of symmetry, actually, is here at 3. Okay, and then we're supposed to find the value of c. Well, the value of c is actually the y-intercept, because if you go into the function and you plug in 0, you have the first equation for a is 10 for y. This is for 0, 10. Is equal to a times 0 squared times b times 0 times plus c, sorry. So if we evaluate that, we know that this term and this term are actually 0. So when I'm all done, I'm end up with 10 is equal to c. That is the value of c for the y-intercept. Okay, so those are one point's coordinates. We need to find another point's coordinates because I only have 2 so far. I have 0, 10, and I have this point over here, 1, 0. Okay. 1, 0. This point up here was 0, 10. So by symmetry, I know that I can go across and measure this distance here to the axis of symmetry, and it's going to be the same distance on the other side. Okay, so that distance right now, we have x equals 3 up top there. So all I have to do is show that x is equal to 3. So the distance between 3 and 1 here is 2, or the distance between 3 and 0 is 3. So let's use that distance, okay? So if this distance is 3, then 3 plus 3 is 6. Okay, so I have those two distances there, and I can figure out the coordinates of another point over here, 6, 10. And similarly, down below, I have this other point, the other x-intercept, which is question C. Again, the distance down here was 2. So I just go 2 to the other side of 3, and that's 5, I think. So I have question C if I want to get to that. All right. So now how do I find A and B? So the easiest way is to use the TI-84 and just do a quadratic regression. So again, we have the 3 points. We're going to put them into L1 and L2, do a quadratic regression. Okay, so I got x is 0, y is 10, x is 1, y is 0, and then I can put in x is 6, y is 10. Okay, so switch over to our TI-84 here, put those points in, edit, L1, I got a 0, 10, 1, 0, and I put in the other y-intercept there, but excuse me, the other x-intercept, but let's put in 6, 10 for the third point. Enter, arrow right, go up, make sure the x's and y's line up, enter, and then do a quadratic regression. So quit. Let's do stats, calculate, quadratic regression. And then I have those in L1 and L2. I can store the equation in vars if I wish. I don't have to. I put it in as a function. Okay, it's going to be in Y1, and then calculate. So now I have the values for A, B, and C to answer the question. 2, -12, and 10. Okay, so this first answer was, again, the value for C. Second answer was the other x-intercept, which was at 5, or you could put 5, 0 if you wish for the coordinates, or 0, 10. And then A is equal to 2, B is equal to -12, I think is what we had. So we have the equation by using a quadratic regression. You also have the option of writing 3 equations, 3 unknowns. So again, your y-intercept, or let's not even do the y-intercept. Let's use 3 other points. Let's use the x-intercept. Okay, so equation 1 for 1, 0 is going to be 0 is equal to a times 1 squared plus b times 1 plus c. And then, sorry, I know that c is 10. And then the other x-intercept, excuse me, is 0 is equal to 5, 0, 5, 5, 0. Okay, so 0 is going to be equal to a times 5 squared, b times 5, plus 10. So again, I can solve that using polysmelt, or I can also just do elimination. So I have 2 equations, 1 and 2 there. So the first equation is a plus b equals -10. I moved the 10 to the other side. The second equation is 25a plus 5b equals -10 again. So again, I can do that in polysmelt or elimination. You want to try polysmelt? We'll do that. Okay, so we need to go to the apps and do polysmelt 9, and then simultaneous equation solver. And next, no, I want 2 equations, 2 unknowns. Now we go up here to that key to do next. And then I have an A and B equation, 1a plus 1b equals -10. And then I have the other equation, 25a plus 5b equals -10 again, because of symmetry. Okay, and then I just solve that. And I get A is equal to 2, B is equal to -12, and C is equal to 10. Next question. Okay, so we got this reciprocal function here. something over x more than likely. We have a vertical asymptote. Didn't ask that question. Need to ask the vertical asymptote question at some time. Again, the vertical asymptote is at x equals 0. Right? Okay. Write down the value of f of 1. F of 1 means that x equals 1. So if I go up from x equals 1, I have, that's actually right at point A. Okay, so point A is 1 comma 3. So I have my answer there to put on the answer sheet, 1 comma 3. And then the tangent is negative 2x. Plus 5. So you could draw that line really quickly if you wish. That's a gradient of negative 2 and a y-intercept of 5. And then you can see its tangent at A. So the normal line is going to be perpendicular to this line. So the normal line is going to look something like this. All right. So with the right angle here. We know how to find the slope of a normal line. A gradient of a normal line is just through the inverse reciprocal. So here is actually m, the gradient, m1, okay? And we're supposed to go perpendicular to that to get the equation for our red line, okay? So again, our first answer was 1 comma 3. F of 1 is 3. Okay, f of 1 is equal to 3. So again, that's in the reciprocal function itself. And then m1 is equal to negative 2. And then for the perpendicular line m2, it's equal to negative 1 over negative 2. That's equal to 1/2. Okay, so now I got to put that into some version of a straight line. I could do y equals mx plus b. See, I know m, I know y, and I know x. Okay, so y was 3. 1/2 for m, 1 for x. Solve that for c, and you get 5 over 2, or 2.5. Next question. I'm sorry, I didn't finish that question. You have to convert that c is equal to 5 over 2. You have to make that into standard form with a, b, and d as integers. So let's rewrite the equation. Y equals 1/2 x plus 5 over 2. I think I got to multiply everything by 2, and you get 2y equals x plus 5. Rearrange the equation, and your final answer should be x minus 2y plus 5 equals 0. Okay, this next question, I think we're going to have to do some work on the calculator. You're given 2 equations here. I can put this equation, this function, into y1 and this function into y2. Let's try and answer the first question, though, before we do that. Jasanti saves some money. How much is it every month? Well, you look at this equation, and it's actually the gradient. It's a rate. So that rate is 400 per month, and then I multiply it times months, and I get how many US dollars per month he saves. Okay, he started with 2,000 in his account. Okay, that's the y-intercept for that straight line. He started with 2,000. Okay, so you just have to use that equation of the straight line in y2 and the equation of the exponential of the car depreciating 5% every year. It's losing 5% every year, that car. That's how we get the 0.95 base. And we put those in the calculator, and we should be able to find out how long it takes for Jashanti to have gained enough money to buy that car. Okay. So let's look at the calculator here. 8,500. Go to y equals, quit out of our app from before. Y equals, clear. Y1 is 8,500 times 0.95 or 0.95. Let's do it the European way. To an exponent of x. Okay, so that is our car depreciating function. We also need the savings function, 400x, $400 per month, plus his initial $2,000. So we're looking for the intersection of those two curves. Look at the graph, we got nothing. Okay, so kind of scary, but what we really need to do is, oh, there's a red line appearing. So what we need to do is zoom fit. So go to the bottom of the screen here, zoom fit 0. All right, and if I do that, normally the window will be changed so that I can see an intersection, which I see over here on the right-hand side. So the standard procedure, second, calculate, intersect, hit enter 3 times. 1, 2, 3. And then I have the x-intercept at 8.64 months. So that's going to be our answer, but I don't think it's the best answer. IB will accept that, but I would round it up to 9 months for the answer. Okay, let's get down to our answers here. All right, so the first answer was 400 per month. And then we got 8.64 months. And then C. Jashanti does not want to wait so long, buys the car early, and she wants to see how much money she needs. Okay, so basically we got 2 months here. 2 months is going to be our variable where we're going to evaluate it. So I'm going to evaluate both of those functions at 2 months. Okay, so I need to look at, okay, B was just an intersection of Y1 and Y2, as I showed you. And then C, I need to evaluate each function. So I'm going to just use the functions that I entered and look at Y1 and Y2. I'm sorry, Y2 of 2. So these are functions that are already programmed into the calculator in Y. So I'm going to use those functions, evaluate those functions. So you can punch those numbers directly into your calculator and no problem. You can do it that way. But I would just like to use the vars button. So I'm going to use vars. And then I'm going to evaluate the function. So I need Y1 of, which one's going to be bigger? Yeah, Y1 is going to be bigger. So let's look at the Y1 vars, Y vars, y1 of 2. All right, so that just plugs in 2 to that function, and you can see it's 76, 71, and change, right? Okay, and then y2, same procedure, y2. And the parents got to make up the difference between these two sums. So basically, there's our workings. 76, 71, 25 minus 2800. I can go up and grab those on the TID4, no problem. Enter, minus, grab this other one, enter, enter. Okay, so she needs 48, 71, 25 from her parents to buy the car. US dollars. All right, next. Okay, there's the, all right, question 4. We're given 6 graphs here, and we need to match them to some indications on A, B, and C and quadratic function. So remember the smiley face is A is greater than 0. So we can write that on our upward turning quadratics. And then A is less than 0 on the frowny face quadratics. All right, and then C is the Y-intercept, as we saw in the other questions, so we can just look at where the Y-intercept is here. C is equal to 0. Here C is less than 0. Here C is equal to 0 again. Here C is greater than 0. C is less than 0 here. And C is greater than 0. So the only thing that's missing really is B. So the effect of B is from transformations. Basically, if B is positive, it's moved to the left. If B is negative, it's moved to the right. But we can eliminate some of these options by looking at some of the other functions. Okay, so this graph 5 is actually y equals x squared, perhaps. But again, A and B are equal to 0 on this one. Okay, and then the other ones are, okay, it looks like graph 6 hasn't been moved left or right. So no horizontal translation there on that one. So we can fill in the answers based on the indications on the next page. So the backwards one is graph 1, that A is less than 0, B is greater than 0, C is equal to 0. That's actually graph number 1 down here. Okay, and then 2 is A is greater than 0, B is less than 0, and C is greater than 0. Six, 3, 5, and 4. Okay, so those are the answers. You know, if you don't know the effective transformations, we could just go into our calculator and make up some numbers, okay? So again, y1 for the first function, it says that a is greater than 0, b is less than 0, c is greater than 0. So I could just do 1x squared minus x plus 1. Okay, and I could graph that on my calculator and take a look. And I could do similar ideas for the other ones, make up numbers, put them in to the calculator, graph it, and try and match the graph to the calculator. Okay, the last question is Violetta is making a garden plot here that's rectangular. Okay, and we're supposed to answer this on a different piece of paper. So it could be because it's a paper 2 question, 14 points. Okay, so show that the width of the plot in meters is given by 100 minus x. Well, you're given information up above, of course, that there's 200 meters total of fence, and the length of the plot, as we can see in the diagram, is x meters. So recall, how do you express perimeter in a formula? Again, A5A. I have to write the name of the the name of the question, the number of the question. Specify that in our workings here. So 5A. Again, we're supposed to show that we're going to use the perimeter of the fence. So basically 2L plus 2W is perimeter, right? Okay. And again, we're told L is actually X in Violetta's plot. And we're also told that the perimeter of the fence is 200. Solve this equation for W. Subtract 2x from both sides. Divide both sides by 2. And we have what the IB would like us to have is 100 minus x. Okay, so this is the width, and the length was x. So again, if we want to plot the area as question B asks, it's just length times width, right? A is equal to L times W. So all we have to do is substitute A as a function of x is the length x, and we just found W is 100 minus x, which will give us a quadratic function. If we expand the brackets, we can see that. Okay. Violetta wants us, she wants to maximize the area of her garden. So what you have to do is use the vertex for this point. Okay. So where is the vertex? Again, it's at x equals negative b over 2a. Okay. So we might have to expand those brackets above so we can find out what a and b are. 100x minus x squared. All right. So it looks to me like a is negative 1 here. It's in front of x squared. And b is 100. So again, to find the vertex, it's where the axis of symmetry is. It's going to be at negative b. I'm sorry, b is negative 1. Negative 1 divided by 2a. Got that backwards. Negative b over 2a. So it looks to me like the width is 50. And actually, we can think about the perimeter. It's 50 by 50 for the whole garden. by using our first formula for area, or width, excuse me. Okay, D. Show that the elector earns 5,000 Bulgarian levs per square meter of plot. Well, again, the area of the plot is at maximum 50. So again, I said it's going to be 50 times 50. 50 times 50. All right, that's 2,500 square meters. All right, and again, she makes 2 Bulgarian levs per square meter. So I just multiply that 2 times the area. I'm showing the units to show that the units justify and that it is 5,000 levs when you're done. Cancel your units. We're left with Bulgarian levs, 5,000. Okay, the rest of this is financial, and I would do it all in the TVM solver. I think I'll save that for another video, and that concludes the formative on functions.